Hello, everyone. Welcome to my channel. This is an educational channel dedicated to uncovering some of the uh, great theoreticians in the past who've put their whole life on the line to study something and to write up their, you know, findings after a whole life of work and having their work be ignored. Um, and they've done a great job, some of them. The ones who I've covered on this channel, who I am going to cover, in my opinion, have done a great job, have made a great contribution, but nobody knows about it because they haven't gotten the kind of exposure that they deserve, in my opinion. So I'm trying to get them some more exposure, at least put the stuff out there so that people can get it if they, are, dedicated. Most of this stuff isn't very easy. It requires a little bit of, you know, uh, motivation to get it, to get some of this stuff. But I think it pays off if you are willing, and it also serves as just kind of a library, putting in these documenting these things, putting them on the record, and that helps me to do my own research and to kind of consolidate my research so that maybe in the future I might be able to actually put this stuff on a red carpet for people, so that it are silver platter on a silver platter for people, so that it becomes a lot easier than it is currently right now. Today is going to be the 159th video that we've done on the reciprocal system of theory from Dewey B. Larson. Mr. Larson lived in was born in 1898, died in 1990. For about 60 years of that time period, the last 60 years of his life, he was trying to figure this reciprocal system out. He crafted it, and through a period of induction, came up with his fundamental postulates, and from there, through a period of deduction, wrote his books on many, many different subjects. And we are covering his 1979 book right now that's called Nothing But Motion. This is the first of a 3-volume set that's called The Structure of the Physical Universe. Nothing But Motion is a book that is primarily on physics and kind of just the physics of his theory. And he throws in a good deal of history of science. And there's a little bit of organic chemistry also. We're in chapter 7 that is called High Speed Motion. Right now, he's kind of going over the clock paradox, which is a little bit of a tweaking of the twin paradox of Einstein, where you have the two twins and one goes off in a spaceship at nearly the speed of light and comes back, and he is still a young person, while the person that stayed back on Earth, even though they're the same age, is an old person, because the clock moves more slowly if you're moving at almost the speed of light. And he switches up, instead of using twins, he uses two clocks. And this is all kind of showing high-speed motion. The basic gist of Larson's theory, articulated in his postulates, is that we live in a universe of motion. We don't have a universe of matter, and we don't have a universe of energy. Energy and matter are merely two distinct kinds of motion, as are every other kind of scientific phenomenon that you know of, magnetic flux, electric current, electric charge, uh, acceleration, energy and matter and motion and pressure, and all of these are relationships, motion relationships, and motion is the relationship between space and time. So these things can all be expressed exclusively and entirely through relationships between space and time. Space and time are reciprocals of one another in the reciprocal system of theory. That basically means that motion is a fraction. Motion is a fraction that has time or space as the numerator and space or time as the denominator. Space and time have their coordinate aspects, meaning that they both have 3 or more dimensions. So that, time and space in that fraction can be time to the third power, time to the first power, space to the second power, or whatever. And you also, that's called coordinate space and coordinate time. And then time and space both progress, meaning that they both, time gets later and later and later, the flow of time. And the flow of space is that space gets farther and farther and farther apart, which was observed by the Hubble telescope back in the 1920s, that all of the distant galaxies are moving away from each other. That is the flow of space. And that's what Larson calls a scalar motion. It's a motion that has a magnitude but has no direction or all directions. And that can be visualized using a balloon and a magic marker. You put a bunch of dots on the balloon with the marker and you blow up the balloon. When you blow up the balloon, all of the dots are moving away from each other, but they're not really moving in any particular direction. That is a scalar motion. And that is how he explains clock time and clock space. Space and time are also only in discrete units. There is no continuum, and there is no, 0.32 units of time. There is only 1, 2, 3, 4, 5 units of space or time. And 1 unit of space in 1 unit of time is the speed of light. The speed of light, 1, is the background, the 0 point, or the origin of the universe of motion. So the speed of light is really where you measure from. Normally in science, you measure from 0. Like when you measure speed, you measure, speed compared to 0. But in the reciprocal system, you measure from the speed of light, faster or slower than the speed of light. And those would be a fraction: 1/2 the speed of light, 1/3 the speed of light, 1/4 the speed of light, and so on. That makes sense for a universe of motion. Motion is always present, and there is no place to go. There is no place where there is not motion. And so, unlike Einstein, who says that the speed of light is the maximum speed of the universe, in Larson's system, the speed of light is the midpoint of the universe, and half the universe is moving slower than the speed of light. That's called the material sector, and half of the universe is moving faster than the speed of light. It's called the cosmic sector. And those two sectors are identical, except that they are reciprocals of each other, meaning that if you understand the material sector, all you have to do is invert the relationships of space and time, and you have the counterpart, which is the cosmic sector. Okay, now we're in Chapter 7, high-speed motion. High-speed motion basically refers to motion beyond the speed of light. And, he's critiquing this clock paradox. And I think I'll just go back a paragraph here. There are those who claim that the paradox has been resolved experimentally. In the published report of one recent experiment bearing on the subject, the flat assertion is made that these results provide an unambiguous empirical resolution of the famous clock paradox. The claim is in itself a good illustration of the lack of precision in current thinking in this area, as the clock paradox is a logical contradiction. It refers to a specific situation in which a strict application of the special theory of relativity results in an absurdity. Obviously, the absurdity is basically that the clock is both moving faster and slower than the other clock. Obviously, the moving clock is moving both faster and slower than the stationary clock, and really there's no way to tell which one is actually moving and which one is stationary. Obviously, a logical inconsistency cannot be resolved by empirical means. What the investigators have accomplished in this instance is simply to provide a further verification of some of the mathematical aspects of the theory which play no part in the clock paradox. This one clearly established logical consistency is sufficient in itself, even without the many items of evidence available for corroboration, to show that the special theory of relativity is incorrect in at least some significant segment of its conceptual aspects. It may be a useful theory, it may be a good theory from some viewpoint. It may indeed have been the best theory available prior to the development of the reciprocal system, but this inconsistency demonstrates conclusively that it is not the correct theory. The question then arises, in the face of these facts, why are present-day scientists so thoroughly convinced of the validity of the special theory? Why do front-rank scientists make categorical assertions such as the following from Werner Heisenberg? Quote, "The theory has, meanwhile, become an axiomatic foundation of all modern physics, confirmed by a large number of experiments. It has become a permanent property of exact science, just as has classical mechanics or the theory of heat." End quote. Larson. The answer to our question can be extracted from this quotation. The theory, says Heisenberg, has been confirmed by a large number of experiments, but these experiments have confirmed only the mathematical aspects of the theory. They tell us only that special relativity is mathematically correct and that it therefore could be valid. The almost indecent haste to proclaim the validity of theories on the strength of mathematical confirmation alone is one of the excesses of modern scientific practice, which, like the overindulgence in ad hoc assumptions, has covered up the errors introduced by the concept of a universe of matter, and has prevented recognition of the basic need for change. Like any other theory, special relativity cannot be confirmed as a theory unless its conceptual aspects are validated. Indeed, the conceptual aspects are the theory itself, as the mathematics, which are embodied in the Lorentz equations, which were in existence before Einstein formulated the theory. However, establishment of conceptual validity is much more difficult than confirmation of mathematical validity. And it is virtually impossible in a limited field such as that covered by relativity, because there is too much opportunity for alternatives that are mathematically equivalent. It is attainable only where collateral information is available from many sources so that the alternatives can be excluded. Furthermore, consideration of the known alternatives is not conclusive. There is a general tendency to assume that where no satisfactory alternatives have thus far been found, there is no acceptable alternative. This gives rise to a great many erroneous assertions that are given credence because they are modeled after valid mathematical statements and have a superficial air of authenticity. For example, let us consider the following two statements. A, as a mathematical problem, there is virtually only one possible solution, the Lorentz transformation, if the velocity of light is to be the same for all. That's from Sir George Thomson. B, there was and there is now no understanding of it being the Michelson-Morley experiment, except through giving up the idea of absolute time and of absolute length by making the two interdependent concepts. It's from Robert Millikan. The logical structure of both these statements is the same and can be expressed as follows. 1. A solution for the problem under consideration has been obtained. 2. Long and intensive study has failed to produce any alternative solution. 3. The original solution must therefore be correct. In the case of statement A, this logic is irrefutable. It would, in fact, be valid even without any such search for alternatives. Since the original solution yields the correct answers, any other valid solution would necessarily have to be mathematically equivalent to the first. And from a mathematical standpoint, equivalent statements are merely different ways of expressing the same thing. As soon as we obtain a mathematically correct answer to a problem, we have the mathematically correct answer. Statement B is an application of the same logic to a conceptual rather than a mathematical solution. But here the logic is completely invalid, as in this case, alternative solutions are different solutions, not merely different ways of expressing the same solution. Finding an explanation which fits the observed facts does not, in this case, guarantee that we have the correct explanation. We must have additional confirmation from other sources before conceptual validity can be established. Furthermore, the need for this additional evidence still exists as strongly as ever, even if the theory in question is the best explanation that science has thus far been able to devise, as it is, or at least should be, obvious that we can never be sure that we have exhausted the possible alternatives. The theorists do not like to admit this. When they have devoted long years to the study and investigation of a problem, and the situation still remains as described by Millikan, that is, only one explanation judged to be reasonably acceptable has been found, there is a strong temptation to assume that no other possible explanation exists, and to regard the available theory as necessarily correct, even where, as in the case of the special theory of relativity, there may be specific evidence to the contrary. Otherwise, if they do not make such an assumption, they must admit tacitly, if not explicitly, that their abilities have thus far been unequal to the task of finding the alternatives. Few human beings in or out of the scientific field relish making this kind of an admission. Here, then, is the reason why the serious shortcomings of the special theory of relativity are currently looked upon so charitably. Nothing more acceptable has been available. Although there are alternatives to Einstein's interpretation of the Lorentz equations that are equally consistent with the available information. And the physicists are not willing to concede that they could have overlooked the correct answer. But the facts are clear. No new valid conceptual information has been added to the previously existing body of knowledge by the special theory. It is nothing more than an erroneous hypothesis, a conspicuous addition to the historical record cited by Jean. The history of theoretical physics is a record. This is a quote from him. The history of theoretical physics is a record of the clothing of mathematical formulae, which were right, or very nearly right, with physical interpretations which were often very badly wrong. As an emergency measure, says Tolman and Goodfield, physicists have resorted to mathematical fudges of an arbitrary kind. Here is the truth of the matter. The Lorentz equations are simply fudge factors, mathematical devices for reconciling discordant results. In the two-photon case that we are considering, if the speed of light is constant irrespective of the reference system, as established empirically by the Michelson-Morley experiment, then the speed of photon x relative to photon y is unity. But when this speed is measured in the standard way, dividing the coordinate distance xy by the elapsed clock time, the relative speed is 2 natural units, 2c in the conventional system of units, rather than 1 unit. Here then is a glaring discrepancy. 2 different measurements of what is apparently the same thing, the relative speed, give us altogether different results. Both the nature of the problem and the nature of the mathematical answer provided by the Lorentz equations can be brought out clearly by consideration of a simple analogy. Let us assume a situation in which the property of direction exists but is not recognized. Then let us assume that the 2 independent methods are available for measuring motion. Methods are available for measuring motion, one of which measures the speed, the other measures the rate at which the distance from a specified reference point is changing. In the absence of any recognition of the existence of direction, it will be presumed that both methods measure the same quantity, and the difference between the results will constitute an unexpected and unexplained discrepancy, similar to that brought to light by the Michelson-Morley experiment. Okay, we're going to stop there and resume tomorrow. Thanks for tuning in. Have a great day.